Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, and here we are going to evaluate this integral involving the famous Dirac delta function. So here we have the integral 0 to pi dx sine 3x cos raised to 4 6x and delta of x minus pi by 2, right? So we'll see how we can solve this integral by using the definition and property of Dirac delta function. So first of all, let us rearrange the terms. So we can write 0 to pi, and here we have sine 3x cos raised to 4, and here we have 6x and delta of x minus pi by 2, and here we have dx. Now see, we define the delta function as the delta of x is equal to 0 for x not equal to 0 and infinity for x is equal to 0. So we know that the delta function is infinite at x is equal to 0, and for all other points except x is equal to 0, the delta function is 0, right? So here if we define delta of x minus a, delta of x minus a is equal to 0 for x not equal to a, and delta of x minus a is infinite for x is equal to a. So here we have x is equal to a, and the peak, the spike is this delta of x minus a is infinity for x is equal to a, and for all other points except x is equal to a, the delta function is 0, right? So if we take this function as f of x, then we have 0 to pi, and here we have f of x and delta of x minus pi by 2 dx, right? Now see, from the definition of delta function, we know that if we have a function f of x associated with the delta function, then the value of this integral is equal to the value of this function f of x at this point, that is x is equal to a. So here we have f of a. So if we compare this integral with this one, then we can see that the bounds are 0 and pi, and the value of a is equal to pi by 2, and f of x is sine 3x cos 6x raised to 4. So the value of this function, using this property, we have f of a, and a is pi by 2. So we have f of pi by 2, and our function f of x is sine 3x cos 6x raised to 4. So we'll take x is equal to pi by 2 in f of x. So we can now write sine 3 pi by 2, and then we have cos raised to 4, and here we have 6 times pi by 2, right? So this is sine 3 pi by 2 has value minus 1, because sine 270 degrees is equal to minus 1, which is 3 pi by 2. So this is sine 3 pi by 2, and here we have 2 times 3, that is cos 3 pi raised to 4. Now see, from trigonometry we know that cos of k pi is equal to minus 1 raised to k. So here k is 3. So we have the value of cos 3 pi as minus 1 raised to 3. So minus 1 raised to 3 is minus 1. So we have minus 1, and cos 3 pi is minus 1. So we have minus 1 raised to 4. So we have now minus 1, and this is an even number, so minus 1 raised to an even number gives us plus 1. So this is minus 1. So the value of this integral is equal to minus 1.